Okay, so binary to decimal conversion. Why is this important? Computers, PCs, uses the binary system. And like we've already discussed, the binary system is a two-state system where something can be either on or it can be off, which is represented by a number 1 or a number 0. Whereas we as humans use something called the decimal system. Okay? And the decimal, for those that don't know the word dec, means 10 states. So instead of just having 2 states, something being off or on, there's actually 10 states. And these 10 states are represented by the numbers 0 to 9. Now, using these 10 digits, these 10 states, I can represent any number known to humankind. Doesn't matter how small or how big it is. So, using the numbers 0 to 9. Now, we need to know how to convert between using 10 digits to represent something to actually only using 2 digits to represent something. Because computers uses 2 digits, humans uses 10 digits. So everything in the world, every word, every letter, or every symbol has an equivalent decimal number. So as an example, you can say let's say the letter A, its decimal symbol will be 10. Okay, let's just say that. I'm not saying that it's true. I'm just making things up here. Okay. So let's say it's a number 10. The letter B, capital B, will be 11, but lowercase b might be 12. Let's say the symbol question mark corresponds to a decimal equivalent of 200, so on and so forth. The computer needs to convert this into binary, or a bunch of ones and zeros, so that it knows that if I have this arrangement of ones and zeros, it means a question mark. Or if I have the arrangement of all ones, it means it's a letter A. If I have it as all zeros, it's a lowercase a. If I've got 4 zeros and 4 ones, it's an uppercase B. And if I've got 4 ones and 4 zeros, it's a lowercase b. All of this conversion, where we convert letters, symbols, and stuff to a decimal number, is actually known as ASCII. If you guys have ever heard of that term or that word, it's called the ASCII standard or the ASCII conversion, where a number has been assigned to every letter, symbol that we as humans use. Now, of course, the computer doesn't use these letters and symbols. The computer does. But if I open up, let's say, Word, and I type in Microsoft Word, okay, not just Word, let's say Microsoft Word, and I start typing out a sentence, the computer can't save the letter S. It first needs to convert it into binary. Then it needs to convert the letter O into binary, and then the letter R into binary, and so on and so forth. And then it needs to save that binary or use the binary in memory or save it on the hard drive or transfer it using email or whatever, the actual ones and zeros. So the computer does this conversion, of course, itself really quickly. Normally, we as humans don't need to worry about what is the decimal value for D, and then how do we convert that to binary so that the computer can understand that. We don't really worry about that in normal day-to-day environments. But when we're talking about networks, and specifically we're talking about IP addresses, this is where the conversion from binary to decimal or from decimal to binary do come into play. Because if you start doing very advanced networking, which we're going to talk a little bit about in other upcoming sessions, then this is really important that you know how to do the conversion, both manually, doing it with a pen and paper, or using a calculator to do the conversion. So I'm now going to show you how to do manual conversion. Okay, very simple, very easy. You need to know two things. Okay, before we continue, let me just move my camera down here to bottom so it doesn't interfere with us. We need to know how to add and we need to know how to subtract. Okay, and I hope you guys know how to do these two things. If we want to go from binary to decimal, we need to know how to add numbers together. And if we want to go from decimal to binary, we need to know how to subtract numbers. So you can still use a calculator. You know, it doesn't say that you're not allowed to use a calculator. You can still use it to subtract and add things. Okay, it's just not important. Okay, so let's see how it's done. Now, it's actually a very simple process. You need to know 8 numbers. See the 8 playing inside again? Computers love doing things in groups of 8. You know, 8 things at a time. So 8 things, or 16 things, or 32 things, or 24 things. Loves 8, 8, 8. So we need to know 8 numbers. And what are those 8 numbers? We start on the right. We start with number 1. Then we have number 2, 4, 8, 16, 32, 64, and 128. Now, I don't know if anybody has realized the significance of those numbers and how we get them. All we do is we multiply by 2 every single time. And why do we multiply by 2? Because we're working in binary, which is 2 states. Okay, so actually you only need to know the number 1. And then you need to know that you need to multiply by 2 the whole time. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. And if we follow these maths, the next number, even though it's not really needed at the moment, 128 times 2 gives you 256, and we can times that by 2, and so on and so forth, but we don't really care about these numbers right now. We only need to know these first 8 numbers when we're doing conversions. Okay, so I'm going to do decimal to binary first. And I'm going to take a decimal number, and let's say the number 200. We need to convert into a binary number. So we start off here on the left. Is always step 1. And we say, can I take 128 and minus that from 200? So can I go 200 minus 128? And yes, we can. We do that, hey? So because we can do it, because it's a true value, we will put a number 1 to say that yes, it can be done. And then because I'm lazy, we take our calculator and we say 200 minus 128, and we end up with 72. Okay, then we go to the next number. Can I take 64 and subtract it from 72? So can I go 62 minus 72, minus 64? And again, because it's true, I put a 1 and I do the maths. I say 72 minus 64, and that will give us an answer of 8. Then I go to the next number. Can I subtract 32 from 8? So can I go 8 minus 32? And of course that is false. I can't do that. And because it's false, we replace that with a 0. So I again go, can I do the same with 16? Can I have 8 minus 16? And again, no, I can't. It's false. So we replace it with a 0. Go to the next number. Can I do it with 8? Can I take 8 and subtract 8? Yes, I can. It's true. So we put a 1, we do the maths, and we end up with a 0. And then we go on. Can I subtract 4 from 0? No. Can I subtract 2 from 0? No. And then lastly, can I subtract 1 from 0? No. Okay. So there is my binary number. So the decimal number 200 converted to binary is 11001000. Okay. Nice and simple and easy. Hey, let's take another number. So let's take away all of that. We say this was 200, just so that we keep it in there. This is the decimal number. And let's take the decimal number of, I don't know, 164. Okay, so we do the whole process again. We take 164. Can I subtract 128? Yes, I can. So we start with the 1. We go to our calculator and we say 164 minus 128 give us 36. Okay, we go to the next number. Can I subtract 64 from 36? No, I can't. So it's a 0. Go to the next number. Can I subtract 32 from 36? Yes, I can. So it's a 1. And we do the maths. 36 minus 32. And we end up with 4. So we go to the next number. Can I subtract 16 from 4? No. Can I subtract 8 from 4? No. Can I subtract 4 from 4? Yes. And we do the maths. Can I subtract 2 from 0? No. Can I subtract 1 from 0? No. So the decimal number 164 equivalents to 101000100 in binary. Okay, so very simple procedure, very easy, nothing too difficult in there. Hey, okay, so let's look at the other way. How do I now convert binary into decimal? So to do that, of course, I need to have a binary number. So let's take that binary number, 11001100, and now I need to convert that into decimal. So what we've learned, if I convert from binary to decimal, I need to know how to add. And what are the numbers that I add? I basically add all the numbers where I have a 1. So I've got a 1 at 128, at 64, at 8, and at 4. So I take my calculator and I just say 128 plus 64 plus 8 plus 4, and I end up with a number 204. Okay. Let's take another number. Let's say now we have, let's do this in red, 01010101. So first of all, I see where all the ones. We've got a 1 in 64, a 1 in 16, a 1 in 4, and a 1 in 1. So I will add all those numbers together. So again, I take my calculator and I say 64 plus 16 plus 4 plus 1, and we end up with the number of 85. Okay, so 0, 1, 0, 1, 0, 1, 0, 1 in binary is equivalent to 84 in decimal. And let's do the last one. Let's see what if I've got all ones. Okay, so if I've got all ones, 128, 64, 32, 16, 8, 4, 2, and 1. Of course, now we're just going to add them all together. So we've got 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And we end up with a number of 255. So as you guys can see, the biggest decimal number I can get out of 8 bits is 255. Okay, so now that I've taught you how to do this manually, how to do it with a pen and paper and a calculator that's got very basic subtractions, let me show you how to do this with a calculator if you have access to a calculator. So this is a standard calculator, can do basic maths, plus and minus. To do conversion between binary and decimal, you need to have a programmer or a scientific calculator, okay, a fancy calculator. And then what you can see is we've got these options over here: hexadecimal, decimal, octal, and binary. So let's say we've got a decimal number of 204. And you can see it automatically does the conversion to binary for me. Was I correct? 1100, 1100, 1100, 1100. So I was correct in my assumption. If I had, let me type this in here, the second one, just looking for some space where I can put this so it's not in the way. Let's make this calculator a little bit smaller. That might help. So if I type in this red one, which was, let's just clear it out, 0, 1, 0, 1, 0, 1, 0, 1, and I say what's the equivalent in decimal, you can see automatically it is 85, like we originally worked out. So this is a nice, easy way to do it if you have a scientific or a programming calculator. Of course, you're not always going to have this, and if you're thinking about writing international exams for A+ and N+, specifically for N+, they might ask you to do this conversion, and they will definitely not give you a scientific calculator. They will give you a standard calculator for you to do your calculations on. So you definitely have to know how to do this manually, which is actually very simple.